or sorry, the cases of congruent triangles. So the first case which we will start with is side, side, side. But at the beginning, let me ask you a question about, in case if I will give you this symbol, if I would write C, so we have C, oh my God, C, B, C, T, C. If there anyone can tell me this letters, it donated for what? CBC, TC. If there anyone can tell me what this means? CBC, TC. Is this a word or it's donated for something for a specific sentence? CBC, T.
Donate one specific.
Is there anyone can tell me? No one know? Grade 9, you are here? What the meaning of CBC, TC? And is this related to our lesson today or not?
No.
No. You don't know, Adam? So C related to
what is
tell me.
congruent?
Congruent. Okay, and what is the rest? So we have C, B, C, C, C. Each letter donated for a word in a sentence. So it means what? C, B, C. Does there anyone know in our
Corresponding?
Okay, corresponding. Word corresponding. Okay, corresponding. B for corresponding parts, corresponding parts.
Congruent.
Congruent. Corresponding parts. Congruent is triangles.
Angles.
Are
congruent.
Congruent. Yes. Then CPC, TC means corresponding parts in congruent triangles. Corresponding parts in congruent triangles are congruent, which means when we have two congruent triangles, so we have each two corresponding sides are equal in length and each two corresponding angles are equal in measure. So the word CPC, TC means what again? Grade 9, CPC, TC. This means that
the parts in congruent triangles are congruent.
Triangles are congruent. Okay? Then now we will back to the first case which we are going to study today, which is side, side, side. To verify that two triangles are congruent, we have to check different cases. And this year, inshallah, we are going to study different cases for congruent triangles. And this is today the case which we are going to study, which is side, side, side. If three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Then the two triangles are congruent. Then here in front of us, we have two triangles. What do you notice about the two triangles now in front of you? What do you notice? We said yesterday that we can put a sign over the side if you have the same sign, which means they have the same length. Well, tell me please, what do you notice here? Did you see the side GH? The side GH?
Yes.
And which corresponding side? Which corresponding side it has the same sign?
PQ.
Right? So we have GH congruent with BQ, right? What else?
Yes.
Hmm.
GF and
GF
PR.
common with PR.
And
EF
PR
equal to or congruent with BR.
is
What
and HF and QR.
HF and QR, right? So this is the three conditions which we can verify them to prove that the two triangles are congruent. Then we have each two corresponding sides are equal in this case. We have
Miss Sahar,
this.
I can see the screen.
I made share screen. Make it like this. Sharing or not?
I can see it.
When the class can't see the screen, grade 9. For the first,
Miss, I'm saying
No.
Miss, I'm saying yes
No.
because AB equals DE.
okay, AB equal DE. So this is one condition. What else?
BC equal EF.
Okay, BC equal EF. This is the second
But
condition. We are
but we don't know if AC equal DF.
exactly.
If two sides are equal, then the third are equal.
This is
Yes.
angles. For the angles, right? If two angles are equal in measure, so the third angle should be equal in measure. But I'm talking about the information which he put it in front of us now. Can you prove
Miss,
triangles are congruent?
no,
It depends
no,
on the information which he gave it to us, ya Ahmed. We can say that they are congruent.
no.
There is not
No.
enough information for this. Okay, let's move to question number 2.
Oh.
You can see enough
Yes,
information,
yes,
Yes.
okay, because we have GJ equal KM, GH equal KL, and HK equal ML. Then he gave us the three information which each two corresponding sides are equal in S, so the two triangles are congruent. I'm talking about, do you have enough information in front of you now to prove that the two triangles are congruent or not? Okay?
yes.
What about the third one? The third one. You have how many conditions here? Question number 3.
One.
How many conditions he gave it to us?
One.
One.
One
One.
and
No, two. Yes. Because there's a coming
They
side.
share the same angle.
One.
They share the
Yes.
the same
Yes.
side.
they're the same
Yes.
side. Right. We have reflexive. We have reflexive property here, which is BR. Then he gave us 2. So we are looking for what? For the third condition. Did he put a sign for the third condition?
No.
No.
He didn't put a sign for the third condition. So this is not enough information to prove that they are congruent. What about question number 4?
Yes.
Question number 4, they will be congruent or not?
It will be
Yes,
congruent.
congruent.
Be congruent.
Because we have two sides are congruent and the same in one same side.
And we have a reflexive side, right? XZ
On a common side.
between the two triangles. And then question number 4, they will be congruent. What about question number 5?
Yes.
We have enough
Yes.
information? Yes.
Yes.
Because
Yes.
we can use the reflexive side. What about question number 6?
BC is congruent to AD.
Question number 6, enough
No.
information or not?
No.
Huh?
No.
No.
No, because
They have a reflexive side, but only one condition is fulfilled.
only one condition. Thank you. So the number 6, we cannot prove that they are congruent. Okay, any question about this part? We are going to use distance formula to find the lengths of AB and DF, and the lengths of BC and EF, and the lengths of AC and DF. Then you can.
Ms. Sahar,
Yes,
we will use the formula of square root y2 minus y1
exactly.
over 2.
We will use the formula to find the distance, which it will be x2
yes, x2 first.
minus x1 all to the power of 2 plus y2 minus y1 all to the power of 2. So please, I'm waiting for your answer. I want everyone to calculate the length of AB. So AB, and the other side, I'm looking for the length of DE. And then BC. Send me your answer, please. BC and the length of EF. And the last one, it will be the length of BC, AC. And DF. Okay, grade 9, please, all the class, they should work with us to find the length of the sides. Then you will use
Mid-distance formula, correct?
Yes, the distance formula, please. X2 minus X1 all to the power of 2 plus Y2 minus Y1 all to the power of 2. Then I will choose anyone to tell me the answers. BC equal to?
BC
BC
4.
equal to?
No, FC equal to.
FC equal to, and what else? And BE equal to, right?
Yes.
EB equal to. But he didn't mention for us the length of EF, right? He didn't say the length of EF. But we cannot, we cannot what here in this question? Did you see this part? FB? FB is what? Is a common part. Then, suppose that FB equal 2 centimeter or 5 centimeter or 10 centimeter, whatever. Then it will be 2 times 10 and 2 times 10, whatever. Then we have a common side, which is FB. So we can say that EB plus BF, right? Plus BF,
BC.
it will be equal, so BE plus BF equal what? Equal BF plus FC. I'm correct? Then EF, it will be equal BC. Then the two triangles are congruent. Why? Because we found that each two corresponding sides are equal in length. So the triangle EFD, it will be congruent with the triangle BCA. Understood, grade 9? Understood?
Yes.
So here in this
Yes.
one, we have a common part. This part, if we are going to add it to the both two sides, then we will find that the two sides are equal in length. So this was a question in your workbook, page 68, question number 11. Also in this lesson, we have a part about stable. Then in your workbook, page 67, question number 8 and 9 and 10, we are going to watch a video to explain what the meaning of stable and what the meaning of not, if it's not stable. So let's watch the video together.
Everyone tries whether the figure is stable and explain our reasoning. And we're basing this video off side congruence. So let's look at number 8. This figure is stable, and our reasoning is the figure forms triangles of 6 sides and length. So once you do this diagonal here, it fixes the sides form a congruency that cannot change the shape, and that's by the side congruence postulate. However, on number 9, this is not stable. And that's because there are many possible shapes for the 4-sided figure with the given sides and length. So
I can't see the video.
You can do something like that.
Miss, we are listening only.
or something like that.
Oh my God.
So there's
You can
many
see?
shapes you can make.
No.
We can see the screen, but we are hearing only. We can see the
No,
video.
no. Just a second. Okay, I'll back.
Hi everyone, we're going to decide whether the figure is stable and explain our reasoning. And we're basing
You can see now?
this video off.
Yes.
Okay, I'll
Yes.
start from the beginning.
Hi everyone, we're going to decide whether the figure is stable and explain our reasoning. And we're basing this video off side congruence. So let's look at number 8. This figure is stable. And our reasoning is the figure forms triangles of fixed sides and lengths. So once you do this diagonal here, it fixes these sides to form a congruency that cannot change the shape. And that's by the side congruence postulate. However, on number 9, this is not stable. And that's because there are many possible shapes for the 4-sided figure with the given sides and lengths. So we could do, you could do something like that or something like that. So there's many shapes you can make. That means it's not stable and it doesn't satisfy our side congruence postulate. And for number 10, if this is stable, because it forms fixed triangles here, these diagonals. So we have a fixed triangle here, here, and here, and it cannot change the shape by the side congruence postulate. Then we have one more example. We have a picture frame. The backs of 2 different picture frames are shown. Which picture frame is stable?
In your opinion now, you have 2 figures in front of you. Which one it will be stable and which one it will not be stable? We have 2 figures in front of you. Which figure it will be stable and which figure it will not be stable?
The one with the line through it is stable and the other is not.
Thank you so much. Yes. So this one, the first one, it will not be stable because we can't divide it. We can divide it in different ways, and they will not be congruent by using side case. But the second one, already we divided it into 2 triangles, and those 2 triangles now are what? Are what? Those 2 triangles in the second shape, we divided it by the diagonals, right? And they form 2 triangles. Those 2 triangles are what? Are congruent. Then the the picture in your right side, the right side, it will be stable, but the picture in your left side, it will not be stable.
So based on what we just did, this picture frame is stable by your side postulate. This one's not. So the second picture has the break in the sides to form triangles. We have 2 triangles which cannot change, and that's by your side congruence postulate. And that's it. Thank you. Have a nice day. Bye-bye.